Hi guys, in this video we're going to discuss about the PCI or the physical layer cell identity planning. There are two main cell identities in an LTE network. PCI is limited to only 504 values. ECGI, which refers to the Electron Cell Global Identifier, is unique in a network and it is unique globally with the MCC and MNC, that is the country code and the network code. PCI can be divided into 168 unique cell identity groups with 3 subcell identities within each group. PSI is corresponding to specific downlink reference signal sequence. So the allocation of reference signals and the physical channels depends on the PCI. This is a resource block and these red blocks are the resource enemy for reference signals. This is for PCI 0, where the cell ID group is 0 and subcell ID also 0. This is for PCI 1 and still the cell identity group is 0. This is for PCI 2, this is for PCI 3, and now the cell identity group is 1. This is for PCI 4, this is for PCI 5. So there are 6 unique sequences and this pattern repeats every 6 PCI. When a device turned on, it first carry out the cell search, synchronization, and estimation of the reception quality of the cells, not only the current cell, but also in the neighbor cells. This is for handover if it is connected, or redirection if it is in the idle mode. Cell search consists of frequency and symbol synchronization to a cell frame timing of the cell. This is to determine the start of the downlink frame and then the PCI. Two special signals called PSS, the primary synchronization signal, and the SSS, secondary synchronization signal, are transmitted on the LTE downlink to assist cell search. PSS has 3 different values, while SSS has 168 alternatives. Thus, these two signals form up the PCI. This is a 10 millisecond frame of an TD-LTE cell. PSS is transmitted in the last symbol of the first slot of a subframe 0 and 5. And the SSS is transmitted just before the PSS. This is a 10 millisecond frame of a TDD-LTE cell. PSS is transmitted in the third symbol of the first and sixth subframes, and SSS is in the last symbol of the 0th and 5th subframes. When a device is powered on, PSS and SSS signals will be sent to the device for timing, frequency, and frame synchronization. Downlink reference signals will be sent with channel estimation and measurements. Then the broadcast channel will be sent with the MIB or the master information block. This shows reference signal sequences for single transmission, 2x2 MIMO, 4x4 MIMO. This mod 6 calculation is enough for single transmission, and mod 3 is required for MIMO. PCI planning consists of 4 priorities. Number 1 is avoiding same PCI values to neighbor cells. If we couldn't follow this, then it's possible for neighbor confusions or collisions. It will result in poor retainability and accessibility performance. Number 2 is avoiding same PCI mod 3 values for neighbors in -CR. If couldn't, then the interference on reference signals between cells with the same PCI mod 3 can be very high. The time taken for a device to camp on a suitable cell will also increase. Number 3 is for mod 6 avoidance. This is sufficient for single transmission cells. Uplink reference signals use 30 base sequences. If two or more cells use PCI values where the PCI mod 30 values are equal, the chance of having strong intercell uplink interference is increased. The chance is higher when the neighbor cells are aligned in the time frame and have high PRB utilization rate. And it will cause poor channel estimation of PUCCH, DMRs, if there is no group hopping, and poor estimation of PUSCH, shared channel, DMRs, if GRP assigned, group assigned to PUSCH is the same. There are two assigning methods for PCI. Number one is keeping fixed PSS per side and rotate SSS per sector. This will force collisions to happen on resource elements associated with reference signals, and the traffic resource elements will not receive any interference from co-sited sectors, reference signals. Second method is fixing SSS per site and rotating the PSS per sector. This improves the quality of the reference signals decoding, but it introduces constant interference to traffic resource elements. Because the number of pieces are limited, you may need to reuse them. If we have reserved PCI ranges such as for outdoors, in-building, future expansions, then it will be limited further. If the PCI reuse is too close, then it will cause handoff failures as well. For a neural network, reuse distance need to be higher than 2 times of a maximum cell radius. It requires to keep the reuse interference to 0. If possible, you can use different frequency for the same cell, same PCI cell. When a device receives same PCI from different cells, there will be a collision. When a cell has two neighbors with same PCI, there will be a confusion. This can cause handoff failures. The device can track the data call to RF conditions, then throughput will be slow. For more videos, subscribe to ECPs.